maybe what those variables might stand for. Yeah, so it says find the cost of a team photo and the cost of an individual wallet photo. So I think if we're going to set up our variables, maybe like X and Y, it really needs to be the price of each photo. Does that make sense? Okay, so let's all do the same way just so that we can all kind of agree, or at least our steps will kind of look the same. So let's say, can we say that X is the cost of the team photo? And Y then would have to be the cost of the wallet photo. Bless you. Okay, so there are two different packages, and both packages involved the team photo and the individual photo. Right? What else do we know? Like, do we know any prices? Obviously, we're looking for the price of the team and the wallet pick. Do we know other prices? Amelia, what could we use to help us with that?
The one that's $29 is one team photo and 8 individual.
Okay, so and that's a $29 package, right?
Yeah.
Okay, so that is, like you said, it's one team photo and 8 individual wallet photos. So I'm going to highlight that. First package, la 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 la. It's a whole sentence. Do you think we can come up with an equation from that sentence? What do you think, Christiane?
I did 29 plus x, or equals x plus 8y.
29 equals x plus 8y. Okay, so 29 is obviously the total cost, right? Why is it 1x and 8y?
Because the price of one team photo is like, we don't know it, and the price of one wallet, individual wallet photo is undetermined.
Right, so that's the x and the y, right? We know how many. One team and 8 wallets? Mm-hmm. Yeah. You guys agree with that? I hope you do. That's a good setup. That's a really good setup. Okay, so there's one of our equations with our two unknowns, but in order to have a system that we can actually solve with these two variables, we need 2 equations. So is there a second equation we can come up with? Avery, what do you think?
I said 3550 equals 2x plus y.
3550 equals 2x plus y. So are you getting that from the second package? Mm-hmm. 2 team photos and 1 individual wallet for 3550. That looks really good. Nice work. All right, so do you see how we're trying to draw this information out? We're looking at complete sentences, getting a couple of equations involving our x and our y. We know that our x and our y stand for the cost of each of the different photos, but now we got to figure it out. So I've got 2 equations, 2 unknowns. What do you guys think is going to be the easiest method? Ben, what would be your advice?
Elimination.
Elimination, okay. You guys agree with that? Do you all think elimination would be pretty easy to do? Okay, so is it set up right now? Do we have the pattern of opposites on the y's or the x's?
No.
We don't. Ben, since you suggested it, let's hear what you would do to create that pattern of opposites.
Multiply the top by -2.
I think that's a very smart move. So if I multiply the top by -2, what I get is, let's see here, -58 equals -2x minus 16y. All right, you guys set up? Can you handle it? Okay. Give it a shot. $1.5. So let's see here. Let me do a little arithmetic here. So 15. So is this 2250 right here? Negative 2250? Negative 2250 equals negative 15y. So when you divide by negative 15, you got 1.5. Sounds about right. So y equals 1.5. So that means, really that's $1.50. Do you guys agree with that, $1.50 there?
Yeah. Oh, I'm so dumb.
Yeah?
Wait, I don't know what I did.
Well, let's look at our steps. Did you agree with what we had here? Like Ben's multiplying by -2 idea?
Yeah.
Okay, so then when you added your, sorry, mine's it's frozen. There we go. So when you added,
Sorry, I think when you wrote that down, I must have thought you already did it.
oh, no, huh? No, what I'll typically do, and I hope this is okay, you can do a different convention if you want. What I'll typically do, if I multiply, I'll just write it back down below, just so I can continue to just add vertically instead of having to rewrite.
Yeah, okay.
Okay. All right, so $1.50, that would be for the wallet pick. And then if you plug back in for X, plug back in for a Y to solve for X, what did you guys come up with for your X value? What do you got, Amelia? $17. Okay. Of course, you can plug into any of the equations. We really have 3 options there. You can use any of them to do that. $17 sounds pretty reasonable as far as the way the problem is set up. So, okay, what do you guys think? Questions? Go okay? Yeah.
So if I added the $1.50 back to $17 on total cost, is that okay?
Well, so it didn't ask for a total cost, right?
Yeah.
It wanted to know the cost of the team photo and the cost of the wallet photo. So you were thinking that they wanted you to add those two in the end? Yeah, I get you. It maybe could have been worded a little bit better, like find the, how could they have worded it differently? Find the cost of only a team photo and only an individual photo, maybe if they used the word only or something like that. So, yeah, okay, good question. Anybody else? Okay, awesome. Let's move on to, I think it's number 5. So we take a minute and read this over. And, we're definitely relying on the idea that you've seen these before. So let's read it over really quick, and then we'll talk about that formula and how this works. And we will use a little graphic organizer again to help us get going with this. So it says an executive invests $22,000, some at 7%, and the remainder at 6% annual simple interest. If he receives an annual income of $1,420, how much is invested at each of those rates? So, earlier somebody said, hey, I think this is I equals PRT. What was the word or wording that told you that it would be I equals PRT? Interest. Yeah, interest, simple interest. Yep, so and it gives you these interest rates right here. But I think that annual simple interest is your biggest cue that it's I equals PRT. Let's remind ourselves real quick what the I and the PRT stand for. I stands for interest. P stands for what?
Principal.
Principal. What is principal? It's not how much it goes up at. What did you say, Ben?
How much you put in.
It's how much you start with, right? It's what you put into the investment. So, like for instance, Christiana, if you were my stockbroker and I was this executive, I would actually, isn't this crazy? I would give Christiana $22,000. And I would trust her that she's not going to lose it all. And not only that she's not going to lose it all, that she's going to eventually give me that money plus some more back. And so that's the amount that we start with, right? The amount that I give to my stockbroker. And so that's what we call the principal. What about the R? Rate. T is time. So I don't. Now I want to be really careful about this. I don't think we're trying to find the rates though, because I think the rates are right here: 7% and 6%.
And the time. It's an annual.
Annual. What does annual mean?
1 year.
1 year. Yeah. So I've got my rates. I've got my time. And I've got my overall principal. But look how the question is worded. It says how much is invested at each rate. So what this means then is that I've got $22,000, and some of it's going into the 6%, and the rest of it's going into the 7% account, right? So I'm going to be splitting this up into 2 different accounts. So is it going to be 10,000 here and 12,000 there? Maybe. Right? It could be 15,000 here and 7,000 over there. I have no idea at this point. What we're going to do is we're going to figure out how it's split up. That makes sense? So maybe I'm going to give Alec the 6%, and I'm going to give Jake the 7% for whatever reason. And so I'm going to give him 10,000, him 12,000, or however it's going to work out. Maybe it's 11 and 11. We'll find out in a second. Okay? So we're going to use that little graphic organizer idea, little table. And so let's go ahead and get that started. I am going to, I'll do something like this. I'm going to go a couple of columns here. Okay, so I'm going to go P, R, T, and I. P, R, T, and I. Knowing that I equals P, R, T, I'm just going to get my principal, my rate, my time, everything set up here. So some of these are pretty straightforward to pull out of the question. I mean, William, what are some of the things you see that like we could just immediately bring out of the question, put into our little organizer? What do you think?
Like,
Do I know the principles? Do I know the rates? Do I know the times?
yeah, the rates are 6 or 7.
Sure. So I'm going to say one of my rates, I'm going to write it in there as 0.06 and 0.07. Agreed? What else do I know, just like right away? What do you think, Ellie? Or Christiana, sorry.
The time is 1.
Times are both 1, yeah. So time is 1, time is 1. Agreed. And this is where maybe we got to start thinking a little bit, right? What do you think, Ben?
So for the principal, it would be.
He's still talking.
One of them would be X and one would be Y.
Okay, so let's talk about that. Remember what we said at the start is this person, this executive, is going to put some of his $22,000 in one account and the rest of the $22,000 in the other account, and we don't know how much is going in either one, right? Now, in the past, we set up that split. We set it up in a certain way, didn't we? But now, we're actually going to set it up in your way. We're going to use two different variables. Do you remember when we did these at the start? I asked you guys, hey, how much is going to go into the 6%? Hang on. How much is going to go in the 6%? And eventually everybody said, X dollars is going into the 6% account, right? And then I said, well, how much is going into the other one? And almost universally at the start, you guys said, Y, right? If X is going into this one, then Y is going into the other one. And I'm like, well, we're not quite there yet. We need to do a little bit differently. But now we're ready to handle that, aren't we? Two variables, two equations. And so I'm going to go with what you said, Ben. We're going to say X dollars into this investment and Y dollars into that investment. We're going to set it up just like that. Now, we actually can put a number into the bottom row. So if I take my X and my Y and I add them up, what should I get?
X plus Y.
Right, but what number should I get? 22,000, right? Because how much money did I have? 22,000. So I can put something down into this final row and it'll make sense. Now the middle two rows, or middle two columns, I don't think so much we can do that. Now finish this up, we need to remember the formula is I equals P times R times T. So how about the interest in the top row? Wouldn't it just be X times 0.06 times 1? So I'm going to write that as 0.06x. And then the second row would be 0.07y. And I can get a total here as well. Like so on the left column I can get a total. On the right column I can get a total. What would be the total interest that this person earned? 1,420, right? 1,420. So, we're just trying to organize stuff into a more easily understood format. Do you see your two equations? Where are your two equations going to come from?
The P and the I.
The P and the I. Yep, the left columns, right? All right, so here we go. First equation. First equation is coming from this. X plus Y equals 22,000. Second equation coming from here. That would be 0.06x plus 0.07y equals 1,420. Okay, two equations, two unknowns. There's some preliminary work we should do. What do you see we could that we could do that make this a little bit simpler, like easier numbers? What do you think, Rocky?
Multiply by 10, 100.
Yeah, the bottom one gets multiplied by 100. Yeah, I think that's a very smart idea. So I'm gonna go ahead and do that. I'll just write it over here. So if I multiply by 10 or 100, like you said, that's going to give me 6x plus 7y equals 142,000. So 142,000. Now let's think one step ahead. What method would you guys like to use to solve this system? Would you like to use elimination, substitution, or graphing?
Substitution.
Substitution. Do you guys agree with that as a good method? Is it perfectly set up for substitution right now?
Multiply by 6.
Subtract x from the top.
If we're going to use substitution, we're either going to have to subtract x on the top or y from the top. That would make the most sense. I'll go with what you said since you said it first. So this one would become y equals 22,000 minus x. And then in the other equation, wherever I see a y, I can replace it with 22,000 minus x. So I encourage you guys to use that substitution method to try to solve this and get our x and our y. Give you guys a few minutes to do that. All right, let's take a look here at what we've got. I'm going to use substitution with this. So wherever I see a y, I'm going to put 22,000 minus x in the other equation. So that could look like this. 6x plus 7. There used to be a y there. I'm going to replace it here in a second. Equals 142,000. So I'm going to remove the y from that second equation and replace it with 22,000 minus x. What property gets used a lot with substitution? Distributive, right? So I'm going to distribute the 7. So it ends up being 6x. 7 times 22,000, is that 154,000? Okay, so 154,000, don't forget it's minus 7x, equals 142,000. So at this point, I think we can write negative x plus 154,000 when we add our like terms. And then finally subtracting 154,000 from both sides, I get negative 12,000. And then can't you just multiply both sides by negative 1 or divide by negative 1? So you end up with positive x equals 12,000. So it looks like $12,000 is going to go into which investment?
The 6%.
6%. So we're going to say $12,000 at 6%. So then how much is going in at 7%?
10,000.
Because the total was 22, right? So you could plug back in and get the 10,000 from any of the equations. We would say 10,000 at the 7% interest, and we've got it. So do you have any questions about where any of that stuff came from as far as the substitution steps? You guys are getting, I sense you're getting really good at substitution, elimination, and all that. That's encouraging. How do you feel about the setup? Does that feel like something you need to practice a little bit more?
Yeah.
I hope it does. Hope that you will practice it just a little bit. I feel like if you can do a couple of these on your own, then you probably got it. Okay, let's look at our final example. I believe it is number 7. So flip over there. Well, hopefully this will help you. Hopefully you see a good method on how to do this. Okay, so let's read this together. We can draw maybe a little picture here. It says how much 1% hydrocortisone cream and how much 5% hydrocortisone cream must be mixed to make 10 ounces of a 2% cream. So really what you've got going on here is you've got, I'll just draw a little container here. This is the 1% cream. It's getting poured into some other container, and there is a 5% cream getting poured into that same container. So if you think about it, if you're pouring some 1% in and some 5% in, I want you guys to think about a realistic situation here. What are the possible results of this as far as the percent of cream in the mixture?
6%.
Definitely not 6%. Say again?
Anything lower than that.
Anything lower than what?
5.
No.
Anything lower than 4.9.
You're halfway there. Anything lower than 5 and
Oh, and higher than 1.
Higher than 1. So if you take a 5% and a 1% and you mix them together, the most you could possibly hope for is something just slightly less than 5, right? And the lowest you could possibly hope for is something just slightly bigger than 1%. You mix those two percentages together, you don't get 6%, you get something between 1 and 5. And so the fact that they asked us to find, what we got to do to get a 2% cream, that does make sense, right? If I said take a 1% and a 5% and give me 30% mixture, it makes no sense. You can't possibly get more than the highest concentration. You'd get a negative amount for one of them, I agree. So we've used a graphic organizer for this in the past, so I'm gonna start making my graphic organizer here. You guys should do the same. So here we go. Here's what maybe it could look like. Hey, how's it going?
Good, how are you?
Yep, good. We're making a video, so if you want to go back and watch the first part, I would suggest it. What's up, Sam? Amount, concentration, and final. So concentration speaks to the percent, right? It's 1% cream or 5% or 2%. Those are the concentration levels. Okay. So let's go ahead and fill in some of the stuff we've got in the chart here. We know the concentrations, don't we? We know that our first concentration is 1%, so I would put 0.01 right there. We know that the other concentration that we're trying to mix into this is 5%, so I would put 0.05 right there. And then what is kind of what's the mixture concentration, Rocky? The mixture concentration.
0.02.
Yeah, 2%, 0.02. So Rocky, let's talk about the amounts now. Do we know how much of the 1% or the 5% we're going to put in there?
No.
So we got to use variables, right? What do you suggest for variables? Okay, so we'll go with X for the, X ounces of the 1% and Y ounces of the 5%. And then 10 ounces is what we want, right? So 10 ounces of the 2% for our final mixture. Does that make sense? Now, how do we get the final column? How do we get to that right-hand side? Christiana, what do you suggest?
You multiply all of...
You do. Yeah, you just multiply across. So you'd get 0.01x, 0.05y, and what is 10 times 0.02? 0.2. Agreed. Okay. So remember, the goal is to use systems of equations to solve these. So that means we need two variables, which we've got up there, x and y. We also need two equations. Do you see where the two equations might come from?
Yes.
How would you describe it? Where would they come from?
The final column.
Final column and the first column, yeah. So this is just like what we did with the investment problem we did just a minute ago. So I'll just highlight those for you. Here are your two equations. X plus y equals 10, and then the 0.01x plus 0.05y equals 0.2. So I'll write those off to the side here and see what they look like, see what method maybe appears to be best. So x plus y equals 10, and 0.01x plus 0.05y equals 0.2. Do you see the cleanup work that might be helpful? Multiply by 100 again, yeah, on that bottom equation. So if I do that, multiplying by 100, that gives me x plus 5y equals what? 20. Yeah, be careful. Moving the decimal 2 spots. So equals 20. Now, looking what we've got, here, let me point out the two equations. I got this one here and this one here. Which method do you think is going to be easiest?
Elimination.
Now, this is a matter of opinion. My opinion, I would say elimination is going to be easier because if I just maybe multiply the top equation by what factor? -1, I'll have it. It'll be pretty straightforward. So that's what I'm going to do. If you use substitution, I think that's also a very good choice. this one would be hard to decide which one is actually the better method. So I would go times -1, it'd be negative x minus y equals negative 10. And then we just add. All right, so when we add, we get the x is eliminating, 4y equals 10. Dividing through by 4. What's 10 divided by 4? 2.5. So y equals 2.5. So then what does that mean for x? If we're going to plug that back in, what does x have to be?
10 minus 2.5, which is 7.5.
Yep, okay, so 7.5 right there. So based on the way we set this up, I would say we want 2.5 ounces of the 5% and 7.5 ounces of the 1%. All right. How are we doing? Doing okay? Okay. Awesome. I'll tell you what, let's do one question in our next section, and then we'll stop a little bit early, and we'll talk about something a little bit different. So if you could flip over to that next section. Mind when you see inequality.
Greater than, less than.
Exactly, right. Greater thans and less thans, stuff like that. So do you remember from last chapter how when we graphed stuff like that, we had to decide on the dotted solid and the shading thing?
Yeah.
Okay, so when you look at like a problem like number 1, problem like number 1 is really similar to what we did back in the last chapter, except instead of one inequality line, there's 2 of them. Okay, so let's talk about how that works. Let's graph these one at a time. Let's see if you remember how to do this. If I was just going to graph this first one, x plus y is less than or equal to 3. What do you think is a method? Yeah, what would you do?
Well, I first moved the x over
Okay.
minus x.
Okay, so then if you did that, you'd get y is less than or equal to negative x plus 3. Okay, that works. And then what would you use to, how would you graph that from there?
Start at 3.
Where? Which 3? There's 2 different 3s.
On the y-axis.
Because 3 is the...
Y.
Got it. Okay, so 1, 2, 3. Okay.
So down 1, over 1, down 1, over 1, down 1.
Okay, so oops. Down 1, right 1, down 1, right 1. And you could definitely go up and left, couldn't you?
Yeah.
So up and left, up 1, left 1, up 1, left 1, so on and so forth. You get the idea. So look back there. Is this line, we're just going on memory from before, should this line be dotted like I currently have it, or should I connect the dots and make it a solid line? Amelia, what do you think?
You should make it a solid line.
Why?
Because the line underneath the equality is the line underneath the equality, so that makes it a solid line.
Yeah, the or equal to, it's got the little line, so you make it a solid line. That's right. So I'm going to attempt to connect these with as straight of a line as I can. There we go. Okay, and then the other thing we got to decide here is the shading. So I'll call this region A and region B for right now. What do you guys think? Am I going to shade region A or region B? And how would you decide? Plug in 0, 0. Yeah, so if I do that, if I were to say 0 is less than or equal to negative 0 plus 3, that's really saying 0 is less than or equal to 3, isn't it? Is that true?
Yes.
0 is less than or equal to 3, so that means we would shade in the region that has the 0, 0, and so I will shade in the region below. So give me just a second here, and I will attempt to do that. Okay, so here is my shading for that particular line. Okay, so isn't that exactly like what we did back in the last chapter? So the only other new step here is we're going to graph the other line, and we're going to look for where the shadings overlap. So this other line, what do you guys suggest as a method here? You want to do the same thing that Christiana did? Go to slope intercept?
Yes.
That's fine. So if we're going to do slope intercept, what would be your first step? Subtract x. Okay. So that would give us negative y is less than or equal to negative x minus 1. Are we there? Is that slope intercept? And when you divide by a negative,
Switch
inequality, right, gets flipped around. So dividing by a negative on all the terms, that's going to give me y is greater than or equal to positive x plus 1. That changes a lot of stuff, just dividing by that negative. Okay, so based on that, Ellie, what is our y-intercept?
1.
It is 1. And what's our slope?
Oh, just 1.
Just 1, yep.
1 over 1.
So up 1, right 1, up 1, right 1. Yeah, so up 1, right 1. So we're going to actually be doing this. Routine here, we could go down 1, left 1, so on and so forth. They do look pretty perpendicular. Are the slopes opposite reciprocals?
No.
Sure about that?
They are.
What's the reciprocal of 1?
1, negative 1 over,
Well, the reciprocal of 1 is, no, the reciprocal is,
Oh, 1/2.
no, the reciprocal of 1 is 1. 1 is its own reciprocal. Isn't 1 really 1 over 1?
oh,
So if you flip it, you get 1 over 1. So the fact that it's negative 1 versus 1, they actually are opposite reciprocals. Who knew? Very good observation. Okay, so should I leave that line dotted like I currently have it, or should I connect the dots and make it solid?
Solid.
Same reasoning, right? You got the or equal to. So the only thing we need to decide now is the shading. So you want to try 0, 0 again? Let's try it out. If you plug in a 0, 0, you get 0 is greater than or equal to 0 plus 1. Wait, does 0, 0 work? It does not work. So that means the region that has 0, 0 is not it. Therefore, we would shade above this line. So can you guys see where the shadings overlap? Okay, so if I were to label these regions, there's really 4 of them. If I were to label them A, guys, please pay attention. Please focus. If I were to label them A, B, C, and D, which region would be your answer region?
D.
D would be your answer region. Okay? So really what that means is if you pick out any ordered pair from region D, it will work in both lines. Any ordered pair from region D will work in both lines. Okay? Yes, ma'am.
Could you have used, like, one of the equations, like, could you have put 0 in for x, and then, like, solve for y, and then put 0 in for y and solve for x?
Oh, do the intercept method?
Yeah.
Yes. I was wondering if somebody was going to say that. I figured I would just go with what you guys wanted to do. But I think intercept method would definitely work here.
Okay.
Yeah. Any other question? Yeah, Jake, go ahead.
How would that work on website?
Good question. You'll find out soon. Check out 4.5. I bet you see the shadings overlapping. We'll see. I honestly don't remember. Yeah. Check it out and let me know tomorrow or Monday. Yeah.